How are you doing, Ania?
I'm good. How are you? I got your email, but I ended up doing it anyway, so I don't need the extension. I ended up making it able to do by before 11:59.
Able to do it?
Yes, I was able to complete both of the assignments.
No problem. Yeah, I saw the email this morning, so I
Yeah,
decided
it's
to.
fine. I just did it just in case you didn't see the email. So yeah.
No problem. So let us begin. I'm still preparing your project for the semester. I planned to have it ready yesterday, but there are a few things I want to fix, put there. Make it more friendly. So probably by Wednesday it should be there, and then if you like, we can begin early working on it. So today we'll finish this topic of confidence interval by looking at confidence interval for proportion. I think I opened too many pages here. Just give me 1 minute. Let me close some of these pages I opened. Okay. All right, let's see. So a proportion, let me make it bigger. This side so you can see. A proportion simply means a part of a whole. When you have a one part, then a part of something, Now, example I gave here is the from the U.S.A Today newspaper. There's a feature that stated that 12% of the pleasure boats in United States were named Serenity. So that 12% is a proportion, because it's a part of all the boats, pleasure boats we have in US. So now for proportion, we have P. We use P to represent proportion, the population proportion. P equals population proportion. Okay. So this is the one we are trying to estimate. We try to estimate this P using the sample proportion that we call P hat. Now this page doesn't have the character for P hat, so I'm going to get it from the other page, like I would normally do before, and then return back here. So the P hat, I'll bring this down. So P hat will be, P hat going to be somewhere here. Looks they call it P hat because you have a small cap. Some people call it P cap. I call it P hat. So P hat will be sample proportion. Okay, where P hat is equal to X over N. P hat is equal to a part of the something, that's the X, over the total sample size. And so I'm going to copy this and put it where we have our main workbook. So the P hat equals to that. Okay, so we try to use this P hat to estimate the value of the population proportion P, where P hat is the sample proportion. And we get P hat using this formula X over N, where X is the part of the something, or the part of the sample, or part of the, then N is the total sample. Now, we have another part that we call Q hat. So we get Q hat, again, I'm going to take you to that other workbook. The Q hat will be 1 minus the P hat. So 1 minus P hat give us the Q hat. Q hat equals 1 minus p hat. So when we start using this characters or formulas, you understand this better. So the Q hat 1 minus p hat. Okay. So that gives us this Q hat 1 minus p hat. Okay. Yeah. So with this, we are ready to do that. Of course, we have our error margin, the error margin. Now, in some questions, they will give you the proportion as a percentage. Like this one, they give you 12%. In that case, you don't have to do this part. You don't have to do this part. You just use the percent value. But if they didn't give you the percent value or the proportion itself, then you use this formula to get the proportion. Let's see how this works. It says here, in a random sample of 200 investment advisors, 70 recommended information technology stocks. Give a 95% confidence interval for the true proportion. So our solution, we have that they didn't give us the percentage, so we're gonna use this formula to get our p hat. So p hat to be, we have our x to be 70, and n equals 200, the sample of 200 investment advisors. Okay. Now we can now get our p hat and q hat. So I'll take you to the other workbook, but let me write this down. N is 200 and X is 70. So now we go to that workbook to get our P hat and Q hat. The P hat will be X over N. So P hat equals X over N, X over N, which means, and you know that our X is the 70 and our N is 200. So we have 200, excuse me, okay, let's go this way. 70 over 200, which this we can get from the calculator we have. 70 over 200, we have calculator 70 divided by 200, 0.35. So we got 0.35 for that. So we're going to put it 0.35, 0.35. So I'm going to put it, this X. Okay, 0.35. I'll take this to the other workbook so that we can put it in our work, the main workbook. So that tells us that P hat is 0.35. Next, we get our Q hat. Okay. Now Q hat will be 1 minus P hat. So which we get from here, Q hat, which is like I said, some people call it Q cap. Q hat equals 1 minus P hat. P hat, which means equals 1 minus 0.35, because we get 0.35 for P hat. So 1 minus 0.35 from the calculator, we have 1 minus 0.35 is 0.65. So our Q hat is 0.65. Okay. I'll copy this and then put it in our main workbook. Okay. So our Q hat is 1 minus P hat, which you got at 0.65. Now, with this, we need to get our error margin. For the confidence interval for when it comes to proportion, error margin, there's a different formula we use because this time we are dealing with proportion. So I'm going to move this down to next page so that we have enough room. Okay. Our error margin now becomes, we have the error margin as, formula will be, let me put it, go take you to the where I can put the characters for the formula, which is in the second workbook. The error margin will be E, let me see, I put it this way. Okay, E equals Z alpha over 2, which is a critical value, Z alpha over 2, alpha over 2. So alpha will be here, alpha over 2 times, unlike for the mean, where we use the standard deviation over root n. In this case, we use times square root of p hat, the square root of, we have a p hat, a q hat over n. Our p hat is, okay, p hat times q hat. Q hat. Once you do two examples, you get used to it. But n, excuse me, make go one by one, which is equals to, now remember that we have, it says with 95% confidence. I told you how to get a critical value for different confidence level. It's the same here. Now for 95%, I told you that either you can get it by using the formula I showed you, or you can get it from the table here where they listed it. If the confidence level is not here, that means you have to calculate it by yourself. But it's here. It's 95%, 0.95. The critical value will be 1.96. You can see right here, 1.96. Okay. So you have it as 1.96, which I will now put on our work. 1.96 for the Z alpha over 2, 1.96 times the square root of, okay, I'll have p hat q hat. We have a p hat as 0.35 times 0.65 over n. Our sample size n was 200. So once we have this, we can now have our error margin. And once we have our error margin, all we have to do is to subtract the error margin on the left side and add it on the right side. So let's go to the calculator and get this value. I'm gonna write this down. 1.96 times we have square root of 0.35 and 0.65 over 200. Okay. Let's go and put it in a calculator. So I'll take you there to the calculator. We have it as equals 1.96. Let me make sure you're seeing this. I believe you're seeing it. Okay, times the square root of, okay, p hat is 0.35 Cure hat is 0.65 over 200. Then you close the parenthesis. 0.0661. So you're gonna be 0.066 if you round it to 3 decimal places. 0.066. Okay, write it down. So we go there and put it in 0.066 in our book. 0.066. And then I'm gonna copy it out and then paste it in our main workbook. Okay, there's our main workbook here, I think. Let's see. Okay, show all windows. Right here, that's the main workbook right there. So I'm gonna put this right here. So that is our error margin E. And from there, we can now get the 95% confidence interval. The 95% confidence interval is instead of X bar, we're gonna write P hat plus minus error less than P hat plus error. So let me write it down from the in our main workbook. I mean, in other workbook, so where we can have the characters. P hat minus error on the left side less than P hat less than P, small p is P less than then P hat plus error. P hat plus error. Okay. So that's give us the character we are looking for. So see that's how, unlike the mean where we have X bar, this time we have P hat because we are talking about proportion now. So that means our P hat is 0.35. So 0.35 minus error of 0.066. Okay, you can see this. Okay. So minus error of 0.066 less than P, small p, okay, less than 0.35 plus error of 0.066. So when we do this on the Desmos, we have 0.35 and 0.066. Okay. So we'll go to the calculator and get this value. We have 0.35. Okay, 0.35 minus 0.066 give us 0.284. Okay. Now 0.284. So we'll go and put it in the left side. Have 0.284. Okay, less than P, less than, if you add it on this side, we'll add it, we'll get changes to plus 0.416. So 0.35 plus 0.066 give us 0.416. 0.416. Okay. 0.416. So this one means 0.284 means 28.4%. 0.416 means 41.6%. Remember, this question, it says in a random sample of 200 investment advisors, 70 recommended information technology stocks. Give a 95% confidence interval for the true proportion. Now, this thing, we can say that the conclusion here is conclusion. So we can say, okay, with 95% confidence, 95% confidence that between, here we have 28.4% to, so we have 41.6% of investment advisors comments information technology stocks. Information technology stocks. Any question for me?
No questions.
Okay, good. Now, in this example, they didn't give us the percentage as proportion. They give us the sample and the X value. Sometimes when they give you the percent proportion. In that case, you don't have to start doing P hat equals S per N. Like in this example here, they give us the percent proportion. Oh, they didn't give us on this one here. Now look at this example here. I think this is the one, number 17, where they give us the percent proportion. Okay, it has okay, make it 20, okay, or 18. Okay, look at this one. It says a survey of 200,000 boat owners found that 12% of the pleasure boats were named Serenity. Find the 95% confidence interval for the mean. So in this case, we have you have solution. Now they give us the N as 200,000 of them. So this is a small n, not capital N. And so now we have proportion P hat. Going to be P hat is 12%, which is 0.12. So I'm gonna go take you to this our other workbook. So have P hat equals 12%, which is 0.12. And of course, you know that the cure hat, excuse me, you know that the cure hat is 1 minus P hat. So let me put this one first in. We have it here as 12%. Okay, which is 0.12. Now Q hat to be 1 minus 12%, 1 minus P hat. So I'm gonna take you there so we can get our Q hat. Now Q hat, I have Q hat equals 1 minus P hat. P hat, which is 1 minus 0.12%, 0.12. 1 minus 0.12. We can get it from our calculator. 1 minus 0.12, 1 minus 0.12 give us 0.88. so that we can put it there 0.88, 0.88. Okay. 0.88. What is it? What is it? Right. Okay, right here. Okay, 0.88. Okay. Now, with this, we can now look for our error margin. The error margin, so that our error will be, now it says 95%, or so that our Z alpha over 2 for 95%. Like I told you, you can get it from this table, the statistical table. For 95%, you can see here it's 1.96. Now, if the confidence level is not here, like I explained, you get it by your own calculations. Now, but it's here 1.96. So for our error margin, the formula we use for our error margin is error equals Z alpha over 2, Z alpha over 2, Z alpha is right here. Let me see. It's gonna be somewhere. Okay, alpha over 2. Okay, times. Okay, square root of. We have P hat times Q hat. P hat, which is this one here. Okay, times Q hat. Okay, Q hat over N. Excuse me. Which is the alpha over 2 is 1.96. As we found from the formula table, 1.96 times we have square root of, okay, we have this. Our P hat is 0.12, that's 12%. Times our Q hat is 0.88. But N, our sample size N is 200,000. We are sampled. Now let us get this from the calculator. I'm gonna write it down. We have 1.96 times square root of 0.12 times 0.88 over 200,000. So that's going to our calculator. We'll find it okay here. 1.96 times the square root of 0.12 times 0.88. Okay, close it, divided by 200,000. And close the entire parenthesis. So we got 0.0014. So we have 0.0014. Okay, just 1 minute. Check. See. Okay. Now, excuse me. I'll take you to our workbook and put it there, then transfer it to the main workbook. Okay. 0.0014. Okay. All right. 0.0014. Now with this, we can compute the confidence interval using the formula we used before. It says P hat minus error. Okay. Now, 95% 95% confidence interval is given by this formula, p hat minus error. So in that case, our p hat is 0.12, 0.12 minus error of 0.0014, less than p, which is the proportion we are trying to estimate. So less than p, less than 0.12 plus 0.0014. So that gives us the confidence interval we are looking for. So here we have 0.12. I'll take you to the calculator. 0.12, 0.12 minus 0.0014. You get 0.1186. And if you add it, so that we don't have to come back here, you have 0.1214. So now that means that when we go to our workbook, we'll see that this part, 0.12 minus 0.0014 will give us the answer of 0.1186. It's less than p, less than p. As on the other side, we have 0.12 plus 0.0014 give us 0.1214. Now, conclusion. We can say with 95% confidence, or we can say we are 95% confident that between, sorry about the noise, they're doing they're cutting grass outside. So we can say that with 95% confident that between here, this 11.1186 means 11.86%, 11.86% to here we have 0.1214, 12.14%. This is about the pleasure boats of the pleasure boats are named Serenity. So, any question? Any question? Any question, class? Hello, everyone. Can you hear me?
No questions.
Okay. Excuse me, let me answer this. It's very important. Just 1 minute. Hello, Uche. Hello. Yeah, Cambodia guys, I'm in class now. All right. Sorry about that. It was I had to answer it. Anyway, now let us round up by doing a sample size. How to compute the minimum sample size for proportion. Now for the minimum sample size, there's a formula we use, and just a little bit different from the one that we use for confidence interval for the mean. So this formula is this. I'm gonna take you to workbook, write it down, and then transfer it back here. Have so the sample is n equals we have the the p hat times q hat, p hat, okay, times q hat, okay, times. Now we have to get our z alpha over 2 over error squared. Excuse me. Okay. So we have z alpha over 2, which is the critical value, z alpha over 2. The alpha should be, okay, that'll be somewhere here. I think I passed, okay, right? Alpha over 2. Oh, my mistake. Because it's a fraction. So we have z alpha over 2, it's going to be here. Z alpha over 2, alpha over 2 divided by the error margin squared. Usually they give you the error margin. So I'm going to transfer this to the main workbook. So like I said, usually they give you the error margin in the question, and then you can just apply it. So this is the formula we use for getting the minimum sample size. You call it p hat, which is the population proportion. We are trying to use it to estimate the true population, the sample proportion. Okay, p hat. Then q hat we get by 1 minus p hat times z alpha over 2, which is the critical value, divided by error squared. And the answer you get from this, you round to the next whole number. So like I said, this is the formula we use for computing the sample size, minimum sample size. Now, there are a few key points here. Sometimes they might give you what you can use to get the estimates of the population sample proportion. So I wrote here, if some approximation of p hat, as this one, is known, that value can be used in the formula. But sometimes we may not have the approximation for p hat. So I wrote here that if no approximation of p hat is known, then use p hat as 0.5. That is if they don't give you any what you will use to approximate p hat, then use p hat as 0.5. Let us see this one. Look at this one. It says a researcher. Okay, let's see. I don't want this 95. Okay. Now, it says here, in a random sample, I want the one that use a different confidence level. In a random sample of in a random sample of 200 internet users, 75 buys items from the internet vendors. How large a sample is needed if we wish to be 92% confidence that the sample proportion of the buyers among the internet users is within 0.05 of the true population? That's 5%. If you're going to make a mistake, you're going to affect only 5% of the population. Okay, let's do this. So we have here our n is 200. And our x is 75. Excuse me. Excuse me. So let's find out p hat first. Excuse me. Let's find out p hat. So p hat will be x over n. Okay. So p hat, I'll take you well, I can find the character for p hat. The p hat will be equals x over n, x over n. Okay. Now, which means our x is, I think our x is let me see. Our S is 75, our N is 200. So it's gonna be 75 over 200. Okay, 75 over 200, which will give us from the calculator, we have 75 over 200. Clear this, 75 by 200 give us 0.375, 0.375, 0.375. Okay, so I'm gonna copy, and the cure will be 1 minus this. So let's put p hat first. Cure hat will be 1 minus p hat. So so this gives us our p hat 0.375. So the cure hat will be 1 minus 0.375. So I got cure hat 1 minus 0.375. So I'm gonna get it, then put it back here. I have cure hat. Cure hat is right here, which is equals 1 minus p hat, which is which give us 1 minus 0.375. 1 minus 0.375. So from our calculator, we can get 1 minus 0.375. 1 minus, excuse me, 1 minus 0.375, 0.625, 0.625. This is p hat. This is not 60, which is cure hat, is 0.625. So it's gonna be 0.625. Okay, I'll have it like that. So let me put it in. So I'll put it right here. .625. Okay. Now, with this, we need our Z alphabet. It says confidence level is 92%. So 92%, let us look at the confidence level of 92%. See if they have it here. Okay, they don't have 92% here, which means that we have to estimate it by ourselves using the formula I gave you last time, P over 200. Okay. So our Z alpha over 2, for 92% confidence level. So for the 92% confidence level, we have that Z alpha over 2, Z alpha over 2, the alpha will be, let's see, right here, over 2 will be equals P over 200. P as constant level over 200. 200 because it's remember, a percent is 100, 100 over 100. But since we have two sides, left side and right sides, we use a P over 200. This is just a quick formula. The other ways you can get this, but this is the quickest, which means P over 200, which means 92 over 200. 92 over 200. Okay, which is from the calculator, we have that 92 over 200, 92 divided by 200 is 0.46. Now, 0.46, remember in the table, this standard number distribution table is four digits. So 0.46 means 0.4600. So we have 0.46, have 0.4600, 0.4600, which on the table we can get the number that is closest to 0.4600. I'm going to take you to the table of normal distribution. So 0.4600, we look for it here. See the Z table, table 5, area of the standard normal distribution table. You look inside it here. 0.4600, so we have 45. We have 461, 4608, and 4599. Let us make it bigger so you can see what I'm saying here. So see 0.4599 and 4608. This one is 8 points away from 0.4600. If you do 4608 minus 4600, you get 8, which is 8 points away. But if you do 4600 minus 4599, let me see. 4600 minus 4599, which is 1 point away. So that means this one is closer. Is it closer than this other one than there? So 4599 is closer than 4608. So you follow it to the left. You can see 1.7. You go up 5, 1.75. So that gives us 1.75 for the Z alpha over 2, 1.75 from the table. So I'm going to copy this and paste it in our main workbook. Then we can now finish the work from there. We got everything we needed. The error margin is 1.75 for 92% confidence level. Now we are ready to apply the formula, which is sample size peak hat times Q hat times Z alpha over 2 squared divided by error. So now let me write these values down, and then we can put them in and get our answer right away. So our P hat is gonna be P hat, which is 0.375 times, make sure you're seeing this. Yeah. Okay. 0.375 times for the Q hat have 0.625 times square root of, Z alpha over 2, which is 1.75 over error. Now, for the error, it says how large a sample is needed if we wish to be 92% confident that the sample proportion of the bias among the internet users is within 0.05. So our error is 0.05 squared. Well, because the formula says squared. See? Formula says here. So look at the formula right here. I can copy it from here and paste it here. Then we can put the numbers in. So the required sample size, is, now we can make it bigger so that we can see it. And paste the formula here. Then we can now go to the workbook and do the calculations and put them in. And equals 0.375 times 0.625 times, okay, so I'm gonna put this here and then put this one here and then put the fraction. So our Z alpha over 2 is 1.75 divided by the error 0.05 of everything squared, and that will give us the answer. So let's go there and in a calculator and do it in a calculator. So we have it in this form. 0.375 times 0.625 times, we can now have our 1.75 divided by 0.05, close it. Okay. Now we have 287.109. 287.109, which is, now we round it up to next whole number, which is 288. 288 samples. So I'm going to take you there, put it back in. 287.109, which is 288 samples. We need it. Okay, I'm going to copy this and put it, and that will be the final example we have today. Okay. Now, that's it. We say how large a sample? How large a sample? So we need 288 samples. Any question for this? Any question?
No questions.
So this is our last example. Let me take your names down, and then Mr. Aaron, you can stay behind. We need something to discuss something regarding your assignments. So Aaron, I have you here. Okay, here I have Ania is here. Chambers. Okay. Karina, because excuse me, Taylor. Okay. So I've taken your names down. You are free to go, and I'll see you on Wednesday. And Mr. Aaron, you have a question for me, right?
Oh, yeah. So yeah,
now, you say I sent you the makeup box 2 times. You say you didn't get them?
No, like I checked the email and I don't see anything to click on. Like I clicked the links, but it doesn't bring me to anything.
Oh, okay. Let me see. Let me open that because I sent it. All right. Open this. I have Morgan. Are you in the when we started this semester, there was a platform that I used to send messages to students, and I asked you to. I sent the message. Were you in that platform? When I send it message, it come to you as a text message. Do you have that?
No, I don't think so.
Because that's another option where if I can send it there, you can download it from there. Or maybe your email. I don't know what is wrong with your email, Morgan email. I don't know why. Okay. Now, this is what I sent to you. Yes, I think there is some email. Sent last. Yeah, the other one I sent. Work. I sent you this work. So this work.
Oh, yeah. See, I don't see that. Huh. Let me see. Let me go to my email.
So like if for some reason, no, I sent Karina the same thing and she received it, and then she actually, I've already graded her work. I'm about to send another one.
Okay. Let me.
Message I sent you on the Friday, April 2, 2nd April. Then I when you say we didn't see it, then I sent it again. But it's the same work.
Okay.
Seen it yet?
Looking for it. Let me see.
If you let me download it. It can send it to your personal email if you're not. Are you sure you're not in that remind?
In what?
Remind.com. The app I used to send message, when I send message, it comes to you as a text, to still as text.
Yeah, I don't think I have that set up. Because I'm looking at the email from April's. You said April 2nd, right?
I can send it. What I'm saying, asking, I can send it to that through that. Let me get somewhere here. I open so many things. Let me see if I can check that app. Remind. See if your name is there. If I attach it in Remind, it can come to you immediately. If that one didn't work, that means next option will be to send it to your personal email.
Okay.
Okay, I have Spring 2021. And then it's not there. Yeah. Now, you have a cell phone. I can send you a message to accept. If you accept it, then I can upload it there right away.
Okay.
So I'm gonna send add your name, Aaron. Let's see. Okay, Aaron, right?
Yep.
What's the last name again?
Downs, Downs.
WNS, right?
Yep.
Downs, right?
Yep.
So what's the number again?
202.
Oh, 202.
286.
286.
2993.
2993. Now, when I send this accept, so I can your name will be added, and then I can upload it there for you.
Okay.
I send the message. It will come to your right second right now. So accept.
Okay, cool.
You see it, right?
Yep.
Accept it. Then I can just say type yes, and so I can send this through that. Now you can now download it on your phone, print it out, or then solve it, then scan it, and then send it to my email.
Okay.
Type yes, I think. As you then type yes and respond. So your name is here now. Now, I will send the assignment to you now through this space. Just give me 1 minute.
Okay.
Okay. Now. Okay. Now let me save this. Okay. Now I'll save it now, and next thing I'm going to do is to message. I'm gonna close this. And first one I sent to you was here. Okay. Just 1 minute. I'll have it there. Okay. Now let me attach this. So I want to attach it. Send message. And then I'm trying to attach it, but not send the option for attachment. I think something is blocking it. Just have a patient. I'll find it.
All right.
It's right here. I think what's happening is that the Zoom thing is blocking the space where I can see the icon for attachment. So I'm going to end the class, then send it to you.
Okay.
So that I can see everything clear, where I can click on the attachment. Then send me an email if it comes to your phone. Okay.
Okay. All right.
So I can have enough room to attach it. And the class, so because it's blocked the bottom panel of it is blocking the place where I can attach it. So I'll do it right now. I will end the class now, then I'll attach it. Okay.
Okay, cool. That sounds good.